Friends, this is a podcast to go over the key concepts in Section 2.2 of the AP Stats book. We've spent a lot of time in class doing some things and not enough time, so maybe going over the key ideas. So 2.2, we're talking about normal distributions. And this all starts on page 110 in your book. And these are the things you should know how to do at this point. But if you know those things, it's probably because you spent a lot of time in the book going over them. So I want to just go over some definitions and do some examples to try and make sure that you're in a good place. So when I normalize or standardize a distribution, it means that I force the mean of that distribution to be 0 and the standard deviation of that distribution to be 1. The reason I do that is so that I can compare two distributions. Now, this is the example from class. We said we had a set of blue tests with an average score of 80 and a standard deviation of 6. And a set of black tests with a mean of 68 and a standard deviation of 4. When I normalized, when I standardized them, I made this mean equal 0, and I made this mean equal 0, and I made both their standard deviations equal to 1. And so you can see how they lay out right here. The reason I do it is so that I can compare different distributions, and I can take any single score in either class and compare how it was relative to everyone else in that class. So you can see here that an 80 in the blue tests is just average, whereas an 80 here is 3 standard deviations above the mean and is excellent. So that's why we standardize. Now, you should also be familiar with the 68, 95, 99.7 rule, which tells us that for any normal distribution, 68% of the values are going to be between 1 standard deviation below and 1 standard deviation above. 95% of the values in the distribution are going to be between 2 standard deviations below and 2 above, and that 99.7% of the values in the distribution will be between 3 standard deviations below and 3 standard deviations above. Now, the normal curve is a density curve, and that means that its area is equal to 1, or 100%. That means if the 68% within 1 standard deviation of the mean is taken out, there's 32% left over. And if I divide that by 2, that means there's 16% on either side. Again, because it's a symmetric curve, half of the difference will be on the left and half will be on the right. And that also means that if I go to 1 standard deviation on the normal curve, that 84%, in other words, 16 plus 68, 84% of the values in the distribution are below 1 standard deviation, 16 or above. And you should be able to answer any kind of question related to this layout. By the same token, if I have 2 standard deviations, that means there's 5% left over, and that means half of that, or 2.5%, will be right here, and the other 2.5% has to be up here. So think about now, if I go to 2 standard deviations plus 2 above the mean, what percentage of the values are below 2 standard deviations? You should know that. All right, and if I go to 3 standard deviations, I can't even see what's left, but on this side, it would be just 0.15% or 0.0015 here, and the same thing would be true on the other side. So what does this mean for you? That means if I give you a normal curve, you should be able to label it in this way. This is 0. The mean is 0. And notice that's where the most distributions are. And then I should be able to label that each one of these tick marks is a standard deviation. So that distance, this distance, they're all 1 standard deviation. And I should be able to label this all out. Additionally, if I give you a mean, say a mean of 17, and I tell you that the standard deviation is 3, I should be able to fill in the values that would appear here, and then answer any kind of question like, what percentage of the values in this distribution would be between 14 and 20? You should know that. What percentage of the values are below 11? You should know that. And you should also be able to answer the question in terms of standard deviation or in terms of the actual values in the distribution. So that's your first goal for 2.2 right there.